Hi, I'm Rich with insideHPC, and we're here at SC13 in Denver, Colorado, and we're here at the Asetek booth. And I'm here with Steve Branton. How you doing today, Steve?
Good, Rich. How are you?
Good to see you again. Well, why don't we start at the beginning, Steve? Who is Asetek, and who do you guys help out?
So Asetek is a direct-to-chip liquid cooling company, and what we do is manufacture liquid cooling systems that allow data centers to decrease their total cost of ownership, particularly in the cooling side of the business.
So, Steve, with these highly dense systems in these data centers today, I mean, that's where liquid cooling really does what it does best, isn't it?
Correct. In fact, behind me here we have a 36 kilowatt rack that we're direct-to-chip liquid cooling. We're bringing 35C water in to cool that, so we're cooling it with hot water. We're taking 20 kilowatts of that out of the rack. We're actually bringing it up and over, warming up the hot tub to keep our ducts comfortable. That hot tub is currently at about 119 degrees Fahrenheit. And then we're taking the water back, the additional heat up, and rejecting any of it that remains with a dry cooler. Of course, the advantage of that is we're not doing any compressive cooling, and compressive cooling is what drives up your cost.
Right, so you got those compressors, crunching the freon and all that electricity.
Exactly.
Yeah, okay.
And here, this is just a simple fan and a radiator on the roof.
Okay. Well, hey, can we take a closer look and see how this works?
Absolutely. Let's come on in.
All right. So, Steve, what are we looking at here?
So, Rich, this is a direct-to-chip liquid-cooled server. And what we're doing is we're bringing warm water in here up to this circulation pump, which sits right on top of a CPU, a cold plate on the bottom. So cooling this first CPU, bringing the warmer liquid down through the second pump and CPU cooler and out the back here. What's nice about this system is it's got two pumps in it, and they're in series. Either pump is capable of driving the system, so we've got two-end redundancy.
Okay, so what kind of flow rate are we talking? Are we talking hundreds of gallons per minute? No, nothing like that, is it?
No, very low flow and very low pressure. So about 35 liters per hour, which is a little bit over 35 quarts an hour for my American friends. And very low pressures, about 0.2 bar, which is about 3 or 4 psi.
Okay, and then you basically don't need fans then to blow air constantly, do you?
Now we still use fans because we're taking the GPU or CPU heat out, but we're still cooling memory and other popcorn parts with fans. So that's why I say that in this unit, which is 36 kilowatts, we're actually cooling 20 kilowatts with liquid.
Okay. So why don't we go through what's new at Asetek? Can you show us that?
Sure.
Okay, Steve, what are we looking at here?
One of the new things we have here is the Cray CS300 LC system. And one of the things that's new is that system is now capable of liquid cooling Intel Xeon Phi cards and NVIDIA Tesla K20 cards. So those are both co-processing systems. And we're actually going to be deploying this quarter at Mississippi State University with the Xeon Phi blades in it.
Okay, is that a pretty sizable system?
It's about 5 racks worth of compute.
So, Steve, I heard about an award-winning system that you recently deployed. Can you tell me more about that?
Sure. We've just deployed in June a cluster at NREL, which is the National Renewable Energy Lab here in Boulder, Colorado. It's a 56-node cluster. We did that in conjunction with Aspen Systems. So that's been up and running as a full deployment since June. We're capturing 48% of the heat into liquid, and that's in NREL's new fully liquid-cooled data center. So that was really impressive. They're doing waste heat recovery and liquid cooling.
I read about that. They're very concerned. They wanted to do green computing because they kind of have a green mission, don't they?
Absolutely. It's absolutely on mission for them.
Well, Steve, it sounds like, we were here a year ago showing this technology, and you've got all this adoption since then. You think the sky's the limit? I mean, heat is never going to stop being a problem, is it?
I don't think heat will stop being a problem. And we do want to do our best to reduce that and reduce the amount of energy, because the energy that's going into cooling is really not doing the job. The job is to do the compute, and removing the heat's a necessary evil.
Yeah, and it seems like the kilowatts per rack just keeps going up. They're talking about 100 kilowatt racks someday and things like that. So, yeah.
They are. We haven't seen any of those yet, but